Okay, so welcome to this session and to this talk. I'm Fernando Ramos. I'm an associate professor at the IST University of Lisbon, and I'm very happy to introduce Parisa Ataei, a postdoc researcher at Cornell. She's working with Nate Foster. She graduated from Oregon State University, and this looks like a very interesting presentation. So Parisa, take it away.
And thank you, Fernando. Thank you, everyone, for being here. So today I'm going to talk about differential testing of P4 implementations using CI/CD. Okay, hopefully all of us here have some familiarity with P4 and its reference implementation P4C. But how do we know that P4C is actually correct? The truth is, in some cases, it isn't. And this is evident by the number of issues that have been opened on GitHub for P4C. Our idea is to use differential testing to relate the behavior of P4C to other implementations of P4, specifically Petra. Petra is a clean slate implementation of P4. It's completely independent from P4C. It formalizes the type system and operational semantics of P4, and is implemented in Coq and OCaml. It provides different modes of operation, such as type checking and evaluating a P4 program given an input packet and comparing the result output packet with the given output packet, also known as an STF test. Our methodology is to take all the tests that has been provided by P4C and run them on P4C and Petra and compare the output. But what do we mean by running them on P4C and Petra and comparing the output? I mean, for every test that we have, for every P4 program that we have in our test data, we run them, we want to see whether P4C and Petra type check the P4 program, whether they both parse it, and whether they both process packets the same way on the available input-output packet. And finally, we integrate this into Petra's CI. So the workflow looks something like this. We have a sample of P4 programs. We type check them using P4C and Petra's type system. They either type check or not. Then we run the STF test using P4C's STF tool and Petra's. The test either passes or not. And then finally, we label each P4 program with the result that we get. For example, P4C and Petra here both type check a program, but P4C is the only one that passes the STF test. As an example, we have this simple P4 program that defines the control plane C. It has a header, meta, and the default intrinsic metadata T that has been defined here. And then it uses my C to basically apply it. While P4C type checks this, Petra doesn't, and Petra complains, it has a big complaint. Don't think about it too much. But what it's basically saying is that Petra expects my C to also have the parameter intrinsic metadata T here. So a way to remedy this is basically just to go in and change Petra's type system. So for our implementation, every time that Petra's developer wants to push some changes, we basically extend P4C's Docker image with Petra, with the current Petra that the developer wants to deploy. We build a Docker container in a GitHub action, and we compare the output of running tests, both the type checking and the STF test, with the labels that we have. The easy case is that they match the new labels that, for example, we get match the old labels. So everything is good and the developer can approve their changes. And the other case is that they don't match. In that case, different cases could have happened. And the first one is that the developer messed something up, so they have to go and fix it and run the CI again. Or they actually wanted to add a new feature or change or fix a bug that already existed. So in that case, they need to go and change the labels and run the CI again. Okay, so in conclusion, we implemented a differential testing tool that compares P4C and Petra's behavior for a sample of P4 programs and integrated it into Petra's CI. We plan to also integrate this tool into P4C CI and keep a public log of current differences between P4 language specification, P4C, and Petra. For example, what features P4C and Petra provide, what are the features that they don't quite agree on and they implement differently, and sometimes even they diverge from the P4 language specification. We can also make this tool more generic by adding more tests, such as PTF testing, or we can also allow to plug in different backends if you want. Thank you. And with that, I will take questions.
Thank you so much, Parisa. Really interesting, and I think really useful for the community. So thank you very much. So I have just a couple of questions. So one is, what's the time to run these tests? So, and do you have any idea, both in terms of time and resources,
Yeah, so
of the
right now,
scalability?
with the sample of the test, the data that we have is the P416 sample. And with that test, with those programs, it takes about 15 minutes for both the type checking and the SDF test.
Okay, okay,
yeah.
Cool. And how about, so in terms of the future, you mentioned that you will integrate PTF testing. So what's the, so is this a big challenge? I would like to understand, so how long will it take? Because I'd be interested.
I would say it's probably just adding a runner to run the PTF test. I don't know on the P4C if that already exists, but on the Petra side, I know that we don't have it, and it probably takes about a week or so to add it, I would say.
Okay, okay, yeah, cool. So maybe just another question. So this works with any program. I mean, for example, if you have programs with stateful memories, now we've seen so many complicated programs doing, all sorts of things.
Right.
Does this work with any sort of program, like with stateful memories?
Yeah, I would say it works with any programs that you want, with any P4 programs. The point is that we are basically just comparing Petra and P4C. So if Petra provides the features that the program is using, it can probably type check it and run the SDF test. The same goes for P4C. So the main point of the work is to basically keep track of the features that P4C and Petra are providing and make sure that the features they're providing, they are aligned with the P4 language specification. So it's basically just like, another way to finding bugs in P4C and Petra.
Yeah. Okay, thank you very much. I think this is really useful. So thank you.
Awesome, thanks.
Awesome.